just had the opening 2 weeks ago, and what we thought is it's probably very good to have like in regular time frame really deep insights, talks, and we'll start today with one talk, and I'm really very proud to have today Stefan Groschupf here with us. And some of you might already know, I just read over the vita, and I'm always very like saying, we are working on the topic already for 4 years, but that's nothing what I read in your CV, over 10 years. So very long working on the topic, very long working on open source things, very successful, and I'm happy to have you here. So
thank you.
This is you.
Thanks. Well, thank you very much for the invitation. I want to do this a little bit more interactive. I know that's a little hard for German sometimes. So who's German and German speaking? Okay. Who's non-German speaking? Okay, good. We will make it English for you today. No. There's a couple. Was there one more? Oh, two? Non-German speaking. Or both?
No, I'm both.
So, I mean, also for the recording, I will just do it in English, and happy to double click on every topic and every conversation, and want to make this interactive. So time is the most valuable thing these days, so I want to make sure you're extracting something. So please feel free to interrupt me. And I think we even have a little time afterwards to have Q&A. So just to make sure I really hit the spot, can I see some hands? Who's consider themselves more on the technical side? Who's on the technical side? Okay, couple, 3, 4, 5 and a half. Okay, and who's more on the business side? The rest. Okay. Okay, so some both. Good. Okay, so that's great, because half is technical, half is non-technical of my presentation, and of course I'm trying to really hit the spot. So if you want to know more, we can dive into this. But let me start maybe with kind of really a 5,000 feet view, and then we can really zoom into the technologies in the what's next, and we can talk about use cases and stuff like this. But let me double click like who you talking to here today. To give you an idea, again, I'm German. I grew up in a beautiful little university town called Halle. Who knows Halle? Oh yeah, okay. I'm very happy. It's really a small town, but we basically, my colleague Frank and me, we started. Today, I would say a data scientist company there in the mid-90s, and we did really amazing, innovative stuff there, but nobody cared in Germany, right? That's the thing. I think the biggest customer we had in the 90s was Hoffmann La Roche in Switzerland, and we did really exotic high-speed text classification algorithms and named entity extraction, what have you. But again, it's a little sad from my perspective. Germany has a lot of innovation potential, but the technology adoption in the business is pretty slow. So anyhow, so what happened is that I got involved with 2 other guys in an open source project called Nutch. Nutch was an Apache project with Dr. Cutting and Andras Bialecki that had as a goal to build kind of an open source search engine. And the idea was Google will be this huge information controlling black hole. We need to put something against that, right? So open source, like we will change the world. We are kind of revolutionaries. with a text editor. And what's really interesting, so what happened though is that very quickly we had huge amount of data, and it was partly structured and unstructured. So we started implementing the Google papers, and actually as a result of that, we created Hadoop. So fun little side effect. Who heard about Hadoop? Okay. Couple tree, good. So, so Hadoop is 1/3 American, 1/3 Polish, and 1/3 German. And in fact, now considered a $20 billion market, the Hadoop logo was created in this tiny town called Halle. And the designer still works with us, and of course we wrote a whole bunch of code. And again, so this is early 2000s, nobody would care, right? I would knock on the door, pick your favorite German big company, and I would say, hey, we have this really amazing next generation data warehousing technology, and we can help you. And they would ask, do you work for IBM? No? Oracle? No? Microsoft? Sorry, yeah, it's like an urgent meeting I have to go to. So that was the experience. So what I actually did, we pushed, I coded in the night, and Frank remembers I showed up at like noon in the office, and he's like, dude, we have real projects, what are you doing in the nights, hanging and writing open source software? But I told him, Frank, this will be big. It turned out to be big. So anyhow, we really moved on, and what we did in 2009 is that we got to the point that we said, boy, we did more than 10 times the same kind of thing. We're trying to get data into this new generation of data warehousing. We're trying to make it simple for people to process the data and make it easy to get data out. So on Friday in November 2009, I traveled to Halle and told all my guys, sorry guys, you're fired. But the good news is I will hire you on Monday in this new company. And by the way, we got $2.5 million investment within 6 weeks, by the way, with a 20-page PowerPoint presentation. And we found this new company called Datameer. So we are 160 people at this point. Our product is deployed in more than 200 places. Madly successful. Again, the interesting experience is we did all of that work in Halle. We still have 60 engineers there. Mostly of our go-to-market is North America though. So let me kind of again get from a 50,000 feet view into then all of the technology. And I'm not sure anyone read that fascinating book, Thinking Fast and Slow. Yay. Amazing. Yeah, it's really interesting. And they also got a Nobel Prize for their research there, Daniel Kahneman. It basically describes the human nature of the brain, the nature of the brain. And the concept here is there's two systems, how we kind of process information, make decisions as human beings. There's system one and there's system two. System one is basically what is used when we're driving a car. It's very emotional, we don't have to think about it. It's a very low energy consumption system. And human nature is that we're trying to make every decision with system number one. System number two, we have to really consciously engage. It requires more energy, and this is when we really have to make kind of quote unquote big decisions. If I ask you, a random question and give you 10 seconds to decide, like, would you invest in Deutsche Telekom stock? What actually happens is that your brain will not think about what's the stock market, what's the market share. The first question the way your brain would work is, do I like Deutsche Telekom? And of course, you all would say yes, so that's why you would buy stock. But again, the really big problem in business, in politics, etc., is that by default, human decisions are made are emotional decisions and not really data-driven and informed decisions. So keep that in mind, and I will come back to that in just a second. I know I'm really far up there. I will get down, and we can talk about compiler optimization in just a second. But it's very important to understand that by nature, we're trying to make decisions quick, and systems need to deliver answers quick. What doesn't mean queries have to be fast. Another really cool thing I encourage everybody of you guys to think about is Moore's Law. Who knows Moore's Law? Okay, all the IT folks, yes. Okay. So Moore's Law basically says every 18 months we can maybe say hardware capacity doubles, right? The speed and the chip speed doubles. What's really interesting though is that Moore's law can actually be mapped to more than just chips. So this gentleman, highly encourage you to read about him, Ray Kurzweil, future researcher at Google, took actually Moore's law and mapped it all back to the Stone Age. Turns out that we have an acceleration of innovation. That means basically every 18 months our innovation, doesn't matter in which area, is doubling. Right? So if you look at again, the first tool human beings used all the way to self-driving cars, it will just double every 18 months. Well, basically, if you keep that in mind and if you can really map this, the result will be by 2020 we will have chips and computers that will think faster than our brain. Right? Deep learning is a big topic at Google. Quantum computing is real. One of my friends is actually literally working on those as a junior professor, and it will come, right? And what's really interesting beyond that is by 2035, computers will be 1,000 times as fast as our brain. In 2035 is actually, it will happen very fast, right? We do have customers that are trying to put an infrastructure in place right now that is there for at least the next 10 years, and again in 5 years the chips will be already faster than our brain. So keep that in mind. So a lot of the things that you think about big data today and what's coming there should be informed by some of those observations. Right? What's happening is, again, and with what Kurzweil is saying, that by 2035 we will make computer supported decisions, right? So we will actually have computers helping us to think. What happens until that is, of course, you saw Google glasses, we all have mobile devices, we don't even think anymore, we just look everything up in Wikipedia. Our life is really moving into a digital age. And that, of course, means that we're leaving a larger and larger trace of behavior, how we interact with each other or with companies, or how companies internally interact with internal systems. We're leaving all that information behind, right? And it's not just structured, but it's also unstructured data, instant log file. So data is really kind of the new oil, and the interesting piece here really is that the oil source, the Ölquelle, is really within your organization, and that's fascinating. And what I mean with, it's maybe a little bit cheesy to say data is the new oil, but we already see that the biggest companies in the world are basically only data companies. Financial service companies, they don't do anything than moving data today, right? That's just the sole. If you think of Visa, it's a brand and it's data infrastructure. It's a credit card company, right? And they moving billions and billions of dollars, and then it's just data infrastructure. Or if you, obviously, telecommunication, I don't even need to talk about it, you guys are experts, right? That's what you guys are doing for a living now. Yeah, and I think there's a huge opportunity, there's risk, we can talk about that as well. But why, let's come a little bit more to the technology, why is Hadoop so interesting in all of this? So, not sure if you can see that, but by 2020 we will have only a linear increase of IT budgets, right? So, I'm sure Deutsche Telekom is quadrupling IT budgets every year, right?
No, reducing.
Reducing, okay. Like in almost every company we work with, right? But you have, again, exponential growth of the data, right? 80%, we didn't even talk about Internet of Things yet, 80% again is in log files and time series data where you track interactions with customers. So there's an IT budget shortfall between a linear increase of IT budgets and the data growth, right? So traditional RDBMS systems like Oracle, Teradata, whatever you use in Greenplum will not keep up with that because it's highly optimized hardware that is not able to scale out that way. Hadoop has a price difference 1 to 50 to traditional RDBMS technology. So there's just no way around, right? So, of course, once in a while, I've worked with folks that work since 20 years in Oracle, and they say Oracle is since 20 years the system of the future. And it's true. Oracle now has a Hadoop distribution as well, but there's a clear change, right? And again, this is because of Moore's law, hardware is becoming so cheap that we need to cluster together. So some forester research, not too much interesting. So how do you think about Hadoop? And you know, the way I think about that might be a little bit different than a lot of other companies promote that. But you guys know VMware. Again, let's just interactive. Who knows VMware? Who doesn't know VMware? Ah, okay, well, who didn't raise his hand? Somewhere in between. Who's not interacting will sing karaoke with me later. How about that? No? So think about VMware, right? We have one physical machine, and what was amazing about VMware is that on that physical machine we can create as many virtual machines as we want, and that kind of gave us freedom in our data center. We could just spin up new services on demand without having physically to install machines. What usually took that long and was really, really painful. Hadoop is basically the same thing, just upside down, right? You take many physical machines and you cluster them together. You have one virtual hard drive, one virtual CPU, one virtual memory. And if you understand Hadoop as a virtualization, really a scale-out virtualization technology, then you can think about use cases and how to use Hadoop completely different than the way you maybe think of Hadoop right now as just a different database. Okay? Because now things turn differently, because now you have more SLA multiplied by the number of machines in your cluster. What basically means storage and compute becomes so cheap that it doesn't matter anymore. And it's really hard from an engineering perspective to get to that point that we say storage and compute is so cheap that it doesn't matter anymore. Because who studied informatics or computer science? Oh, sorry, I should not raise my hand, I didn't. Couple, three, okay, good. So, you know, the way most engineers grow up in German universities is that they learn how to optimize, how to do this with less CPU and less memory and faster. You waste your time, it doesn't matter anymore. People that study computer science today, it just does not matter anymore, right? What is way more expensive today is the human capital you invest into optimizing your software than the hardware you will later spend to run the whole thing on. Think about it, Facebook. You guys know Facebook. It was written in PHP. Every computer engineer, every software engineer would say, what? PHP? Guess what they did? They built a multi-billion-dollar business, and then they hired someone really smart that performance optimized PHP and compiled it in C++. But they first focused on building a business and they didn't care about optimization, right? And that's really important. That's what I'm seeing. It's very important because I keep seeing this in data analytics projects on a daily basis, again, with hundreds of our customers, where they deploy scientists and trying to optimize and create super clean performance, optimized indices, star schemas it doesn't matter. You're wasting your time. You're wasting the time of the company. So let me maybe double click on this. So if we come back to that very first observation, thinking fast and slow, right? We have less and less time to make decisions. The profits, especially in the telecommunication industry, are rapidly going down, right? And pick your favorite industry. It might be retail, consumer packaged goods, car manufacturing. Profits are just absolutely dropping. And what's really interesting is in this global world, we're all on the same level. We all can produce in low-cost income countries. Spinning up infrastructure today is as simple as going to Amazon and spin up with a credit card a few machines, and we can scale it out. Think of Instagram, what they sold for $3 billion with a 5-people engineering team. 5. Zero infrastructure, everything on Amazon. Right? So keep this in mind. The most valuable thing today is time, and we have less and less time to make decisions. But what is getting more and more complex is data. I'm personally not a big fan of the word big data, even though, I'm sorry, we might branded it in one of our first Hadoop conferences that we organized. But if you just have big data, or the word big data, I always joke, is a big buzzword from big companies to make big money, but it doesn't have anything to do with the real problem. The real problem is data complexity. right? If you just have more of the same data, you just buy more of the same already existing infrastructure. The problem for not just telcos, but for every organization is that you have new services that creating new data sets and that you want to enrich and get more perspective of your customer interactions. And it's really interesting. Technology vendors somehow keep focusing on larger, faster, but they always oversee that the problem is complexity. So think of this really, right? This may be, sorry, the projector isn't as strong. This is a manufacturing line, right? So this may be how Henry Ford used to produce cars. And this is how we do data analytics today, right? It's a kind of the same labor-intense process. TDWI, Data Warehousing Institute, estimates it's actually 12 to 18 months change cycle in medium to big size companies to change data analytics and basically just adding one data source, 12 to 18 months. But what we need to get to is really kind of the 3D printing, right? The on-demand insights, again, to kind of overcome that. So let's look at this. Data architecture that we all have in our organizations is basically a three-tier architecture. We first have a process that we call ETL, extract, transform, load. And if data is the new oil, what we do here is we clean it, we transform it, kind of make plastic out of the new oil, and then we melt it into our data warehouse, in our database. Right? It's our Oracle. And the problem here is that we design a schema, right? A number of tables and columns in our table. And the problem is that we define them today with knowledge from yesterday, and then we hope it's good enough for tomorrow. Anybody yet predicted the future? If not, talk to me later, please. I have some ideas and questions. The problem is every organization we're working with, they have some really smart people in the, usually in the basement like me. You know, I'm an engineer and they kept me in the basement for 15 years. And you're really hard trying to think about how do I optimize this data problems and get it into columns and star schemas, snowflake schemas. The problem is as soon as we figured something out, you know, we come back to the business users and say, we figured it all out, we can answer all your questions. And then they say, well, so we just added this new service and we have a new data source, can you please rethink your whole thing? And then you go back, right? And you surface up again, say, I figured it out, here's the problem, this is the solution for the problem. And then, we have a new question, can you add this kind of data source? Right, so the problem is that actually the requirements in your organization are constantly changing, but you're working with a static environment. And even worse, you're putting reporting on top of that. So we can only answer the questions that we designed this whole environment for. Now the problem is every time we have new data, we have to change the schema, we have to update reporting, or every time we have a new question, we change the schema, we have to update all ETL. 12 months change cycle. And that's the problem with every company we're working with. To get true answers to a problem will take a year. Right? And especially if you're trying to build this all manually, it takes even more, and it takes an army of really smart people. Good luck finding those smart people. Anyhow, hiring takes even longer. Now again, this is if you think of my picture, two pictures before. This is the manufacturing line. It's the query you run in your Oracle database is really fast, right? It's highly optimized. It takes maybe a half second to answer a question. The problem is how long does it take to answer a new question? 12 months change cycle in IT. With, you said, shrinking IT costs, shrinking IT budget. Okay, so there's an opportunity. Now I'm coming back to thinking of Hadoop as a virtualization platform. Think of Hadoop as an unlimited storage and compute environment. The only reason we have this is because we had only that much budget for Oracle or Teradata or Greenplum or DB2, whatever you bought, right? If storage and compute doesn't matter anymore, what we can do is we can disrupt that traditional process. What we can do is we can load data as is. We don't need to change it, right? We put it in Hadoop. What we now can do is something that we would never do in Oracle. We do everything as a view, right? Basically a lens system. So cleaning the data as a lens on the raw data, doing a join is just another lens, doing aggregation is another lens, and maybe prediction is another lens. So if we change the way how we want to clean data, what's a very common problem, if you have a new data set, you just switch something down here, and of course it goes all the way through. Right, and that's why if you use that new approach, again, it's very hard to get in people's head, but if you use that new approach, you absolutely shrink the time to insight. And I would again argue that time is the most valuable thing in organizations today. So it requires a new thinking. Again, it's very hard for IT because it basically is counter to what we learned in universities. But we had one very important inflection point. Hardware is cheaper than human beings. And it happened in the last 10 years, where hardware was 10 years ago was way more expensive than human beings. And I'm actually glad. Maybe I saw too many science fiction movies, but I'm really glad that human beings are valued more than hardware today. But again, companies have to make that logical shift. Now, again, the projector isn't really good. I want to zoom in a little bit more on the technology. This is a video of a database hard drive. What happens is that the reading head has to physically move to read every single record, right? So let's see if we say, okay, well, give me all customers at Deutsche Telekom that pay more than $100, whatever, euros, excuse me. So for every customer you want to read, you have to move the reading head. It takes 8 milliseconds, so it depends on the number of customers really, let's say there's 10 million subscribers. If you don't have any optimization, it's just one hard drive, it would take 5.8 days. Now this is again how traditional hard databases work, and of course what they now do, they stack a whole bunch of disk drives together, do RAID systems, scale that out, etc. But here's a hard drive, again, unfortunately you can't see it, the disk is spinning. That is basically from Hadoop. What Hadoop does is sequential data access instead of random data access, what you saw before. It positions the reading head once and then starts spinning the disk. And this is again highly optimized for sequential data imports. Because what happened in the last 20 years is that we couldn't physically optimize moving the reading head, right? It still takes 8 milliseconds the last 20 years. But what happened is that we got so precise at building those spinning disks that we now spin disks with much higher RPMs, and therefore we have much higher I/O rates. So basically that's the major shift in the Hadoop architecture that allows us to be significant faster. So basically, if you have to read 10 million records here again, it takes 1.5 days on a single disk, because, and it's not even a very fast disk, as you can see, because we don't have to physically move for every single record, because 10 million times multiplied by 8 milliseconds is just way more time than position at one and then start spinning it. Does it make sense? Is that IT for engineers with me? Okay. I will pop up again in a second. So now many people will say, oh, well, we have solid state hard drives. They're so much faster than physical disk. Well, guess what? Sequential data access for solid state and even memory is still much faster than random and will be in the future. So again, completely different architecture here that will also in the future allow to have those sequential optimized data stores like Hadoop or Spark or Flink being the future. Interestingly enough, now this is, unfortunately you can't see it, maybe I should show you this. Here, look. It's a tape drive, right? The way the Hadoop file system now works is like a tape drive, because now we position the reading head once, and who remember music tapes? I see some people here that are too young to remember them. Okay, so when I grew up again in the east side of Germany, right? So we didn't have as much amazing technologies in the 90s, late 80s, sorry. So when we had to get to a specific song at a tape, we had to go to the whole tape, right? So I remember that, and even sitting in school with a pen and like spinning the you guys are too young for that. MP3 and beyond. Anyhow, so the challenge here with a disk, with that kind of architecture is that you actually have to go to every single record, right? It's sequential optimized, it's much higher throughput, but you can't jump to individual records. Where with B-tree, as you saw this, the disk drive in the beginning, you basically build your data structure very similar to the index of a book. You very quickly can find individual records. Now, what is interesting though is now, if you guys think that SQL on top of Hadoop might be the right access to data analytics, then again, put all the information I just gave you together, you will realize SQL and Hadoop doesn't make sense. because structured query language that is absolutely optimized to find individual records doesn't work because Hadoop doesn't have a B-tree index. Is that making sense? Right? So if you want to use SQL, and if SQL is the weapon of choice for your analytics, then Hadoop doesn't make sense. Please use Oracle, Teradata, Greenplum, whatever is your favorite SQL, but please do not use Hadoop because Hadoop is built in a completely different architecture. We optimize it for sequential I/O, and again, it's kind of a tape drive. So using a query language, a structured query language, doesn't make sense. By the way, Gartner says SQL and Hadoop is kind of on the peak of inflated expectations. So a lot of people, a lot of vendors really coming into the market say, okay, Hadoop is great, it's this new cheap data warehouse, now let's duct tape SQL on top of that, and then it feels like the cozy old Oracle we're using since 20 years. Again, there's a problem, it's technically not working, and it was never built for this way. That's actually the only point I'm trying to make the last 4 slides. Good. So now everybody talks about the data lake, right? So let's double click on that. If we're talking about the data lake that democratizes data access and it's really able to solve all of our analytical questions, Hadoop as it is today is maybe not the right choice, or maybe some folks using it wrongly. So a lot of folks using Hadoop only for kind of data prepping, right? They kind of clean the data, they cook it down, and then they load it into, you know, maybe Tableau, for example, or Pentao, pick your favorite. So the problem there is they only use it for big data, but not small data, because Hadoop might not be optimized for that. And they're using mostly MapReduce. Of course, that's batch, right? So we can only kind of position the reading head, start spinning, so it takes a while. And then they're using MapReduce APIs, right? It's really painful. And this is really what we're seeing, people, companies talking, oh, we built this big data lake architecture, but actually if you look into this, it's not really that vision implemented that they had, where data access is democratized and where we can solve kind of every analytical question we had. And it's a little bit, I'm in Germany, I have to be careful the language I'm using. So everything is a little more formal here. Augenwischerei might be the right German word. So it's, you know, it's really positioned than what the reality brings. What we really need to do is to get to a point where we have any kind of data operations, not just data preparation, but also analytics, prediction, etc. We need to work with small and we need to work with big data. Right? If we want to truly build that data lake and want to do data democratization, we need that. And that means we need to support different execution engines, not just MapReduce, but maybe also kind of more faster in memory execution engines that support fast and batch. And what we really need is enterprise integration, right? And of course, I talked about different execution engines, and there's an emerging set of technologies that I will talk about a little later that kind of go in that direction, but unfortunately they are used in isolation. People are using only MapReduce, or they're using only Spark, but the real trick is to bring them together, right? To again get that vision implemented that we can do everything. This is just another visualization for fast versus batch, right? So keep in mind that what we're seeing really with all of our customers, every data analytics problem starts with large data, you know, sometimes tera or petabytes, but in the end, people cook those large data down to a few insights was just a few kilobytes. But if you keep in mind, I forgot, Frank, well, how much was it? The human eye can only process a half megabyte a second. That's our sensor. That's our I/O, maximum I/O, half megabyte a second. So you need to cook down data, right? You can't look at a petabyte of data. Metrics not going to happen. Like. So and again, in that context, it's very important to understand that your backend architecture needs to support that cooking down, and at some point, you know, you don't need that container ship anymore, but you need a byte messenger. So that's very important. So again, combining different execution engines. And as I mentioned before, also a big requirement is to bring structured and unstructured data together, semi-structured, right? Because the quantity, 80% of insights in the future will be in log files. And those log files becoming really, really valuable because they are a trace of our interactions. Right, and I give you an example in the telco space, huge ROI You're trying to understand, a lot of telcos trying to understand churn, right? It's the biggest problem. Getting a customer super expensive, you just give him an expensive phone, you want to keep him on board. And then there's a lot of machine learning used to identify when people potentially churn. But in many telcos that we come to, what people not looking at is behavior, right? Is when usage is going down, for example, or when people go on the website and look for new devices. Guess what happens? They not just look at your website looking for a new smartphone, they also go to the competition, and the competition says, well, we pay you the fee you need to get out of your agreement, right? Or first phone cheap, so for free. So there's an opportunity, again, huge opportunity to get a competitive edge by understanding human behavior that is in data sources that are usually not heavily used. And of course, the foundation of all of this is governance, right? Especially in Europe, that plays an even, it plays a big role in every country. I think that, every customer we work with is heavily on encryption and data governance and restriction, what have you. I think it's a little bit more public opinion, or people are more public opinion aware in Europe maybe, but the requirements are pretty international. Maybe in Europe you can use strong encryption mechanisms, but we can geek out about that later. So data governance is really kind of the foundation, the pillars of which you can create that data lake concept and democratize data access. But actually it's not a data lake. Sorry to say that. I personally am not a big fan of that. It's actually really kind of more a system of rivers. Data and organizations are always at motion. It always has to move, especially in telcos, by the way. You have legal requirements in Europe to store data for, I think 24 months now, right? And then you have to purge the data. Data retention is important. Data is always flowing. It's somewhere created and it moves, it's maybe created because you clicked on a device and then the data moves to the cell tower, and from the cell tower maybe over some network elements into a staging data environment and eventually flows somewhere else. And maybe it flows into an ocean, but even then you have currents in the ocean. I maybe stressed the metaphor too much, but it's really data is in motion organization. It's important to understand, and that you have, again, retention requirements with this, etc. And before I really get into this, what we see with a lot of customers is that they are so narrowly focused on getting data scientists in their company. And they're hiring this really amazing mathematician and PhD and data mining. And then you have those, and again, I was one of them, that's why I can maybe make jokes about them. So you come into an organization and you have just no idea about how business works. You're trying to optimize on algorithms, but you do not understand, if you would just add that one data set, that you would get a much broader understanding how customers, for example, churn, or how you can upsell them. Right, so I think what's really, really critical is the integration of data. Again, we don't even need science anymore, because in 5 years our chips are faster than our brains anyhow, right? So I would actually argue that if you want to get ready for the future, the investment needs to be less in algorithms, because we will have deep learning, sophisticated deep learning, open source technology and commercial technology in the next 5 years. There's no question about that, and therefore optimization of algorithms doesn't make as much sense as it makes sense to really truly understand the business and the business challenges. And I'm sorry if I kind of broke that news to this data scientist here. Again, I'm one of you guys, but a lot of companies trying to so aggressively build up those data scientist labs with those really amazing mathematicians and what have you, but they totally forget that what those guys have to understand is the business, right? And really that cross-functional integration is so critical. All right, so what are some of the latest trends? I didn't even check time. How am I on time? Good. So I'm optimized for an hour, so I'm maybe still in. So there's a lot of movement in the Hadoop distribution market. Cloudera, Hortonworks, MapR, they're all trying to set themselves up to be long-term sustainable companies, and therefore they're competing for a business and trying to lock you in. I think that's really important, especially as a company like Deutsche Telekom tries to make a decision which direction they're going with Hadoop distributions. The cool thing is that there's a few open standards like HDFS or Yarn or MapReduce or Spark or things like this. But there's a wave of companies or vendor-specific APIs that I would highly recommend to not integrate with, because you lock yourself in, right? So it's really, really important to understand that I don't know, Ranger or Sentry are very specific to individual companies, and if you integrate yourself with those, you're kind of locked in. And it will be very, very difficult to get out, and it will be very painful, especially as Oracle will buy one of those and IBM the other one. So standardization is a big topic, right? There are some movements there. Keep in mind, again, as you emerging in the Hadoop world, that you really only integrate with those open APIs, and that you push the vendor of your choice into moving their different technology into standardization. It's all open source. What's open source anyhow today, right? What you buy today in licenses are just insurance packages, right? Even if you go to China and tell Microsoft you want to have the source code, you will get it. Maybe if you're Deutsche Telekom, you get it as well. I don't know what your agreement is with them, but I think the future even will be an open source Microsoft operation system. But anyhow, so standardization is very important as you think into how do I move with my data operation system. And then what we see a lot is Hadoop as a service, because especially this fight about customers and that consistent upgrades on the Hadoop technology that is incredible fast emerging, resolved in a lot of companies saying, I'm getting so tired upgrading Hadoop every 6 months that I maybe just go to someone that provides me this as a service. Microsoft is aggressively pushing there. So the way Microsoft, for example, understands the new operation system is that the cloud is the new operation system. So Windows is just the client, and the real operation system is the cloud. So they're massively pushing on their kind of data operation system or data backend in the cloud. So they have Hadoop as a service, but there's other vendors, of course, as well. And if I'm not mistaken, I hope I get credits for that. T-Systems is providing Hadoop as a service as well. Do I get commission?
A drink, minimum.
Maybe a drink. Okay. And then, as I said, given that data governance is really kind of one of the main barriers to entry for Hadoop, especially as we're starting using personally identifiable information, there's a lot of stuff going on. There's Sentry, there's Ranger, there is Falcon, different projects. Happy to go into details, but I don't want to. Do you want me to go into technical details?
Yes.
Okay. Over beers. So a lot of very early stuff around metadata management, change management, encryption, access control stuff. Of course, all stuff you can buy with our product or you can build yourself. I think the most important thing really to understand is Yarn. Yarn, yet another resource negotiator, open source names, they make up stuff. But Yarn is really what I said, is that virtualization layer on Hadoop. Historically, Hadoop was only two services, was the file system and the MapReduce system. Now Yarn is really creating that thin layer over all of the machines that allows you to spin up services, and MapReduce, the file system being one, but now we can plug in things like Spark or Flink. They are really, really exciting, good stuff. And it really is helpful as you think about Hadoop as this scale-out virtualization platform to think what other services can I run there, right? You can run graph engines there, you can run prediction engines there, whatever you want to have. Cascading is a very cool emerging technology, actually emerging since almost 10 years. I had the luck, I was involved a little bit there as well. Think of cascading really as a kind of a next level abstraction of all the different execution engines. So it's basically a Java API you implement data pipeline instructions, create a join, create a filter, create a prediction, whatever. And then cascading is compiling that into different execution engines. So coming back to that observation that if you want to truly implement the data lake, you need support of not just MapReduce, but also Spark and different things. So cascading would do that. It just lifts you a layer up if you want to code. Kafka, really interesting. Data streaming engine, kind of a classical publish subscribe. For the engineers of us, the same thing since 30 years, just a new implementation. You have producers, you have queues, and then people can subscribe to the queues. Back when I was involved in JBoss, we called it JMS, but now we call it, one of them is called Kafka. Interesting technology, also highly integrated with things like Spark. So Spark, as we talked, is, if you think about Hadoop maybe as the file system that works like a tape drive, if you think of MapReduce maybe as CPU, Spark can be thought as kind of a way how you could abstract memory. Again, more as a metaphor here. The idea here is you load data sets into memory, and then you can do iterative processing on that. So develop at UC Berkeley. It will not replace Hadoop because again, it only works basically in memory. So we have a lot of companies that come to us and like, oh my God, the Spark thing is amazing and it will kill Hadoop. And no, right? So again, you will need different engines for different use cases. It's very interesting, but let's do the math. If you have a 10-node Hadoop cluster, let's go crazy, let's say 50 gigs memory per machine, that's 500 gigs of memory. You know, my laptop has a 1 terabyte SSD drive, that's even faster I/O rate to the CPU, so you can install Spark or you can just run it on my laptop and you have more data. Right? So it's a very hyped technology right now. It's interesting, but there's a lot of more work that needs to go into that. I'm really excited about Flink. Flink's kind of what comes after Spark. Made in Germany, so you say that. So a lot of work actually out of TU Berlin. Anybody from Technical University Berlin? Yay! Really cool stuff. Works a little bit different. Maybe you guys know even better. Do you want to talk about that? Do you work on that? Okay, no, good. So in the way Spark works is you load data into memory and you keep it there, and then you do data operations on them. They do a lot of, for the tech folks of us, they do a lot of serialization, deserialization. You need a lot of garbage collection there. Flink is highly optimized on a binary stream concept. So a lot of operations happen on the binary level. That's why it's it's in some cases 3 times faster than Spark and really more optimized for streaming use cases. Again, really cool. Top level project now also at Apache, and also has a really cool cost-based optimizer. So that's something that I think Hadoop is still a little bit lacking if you compare Hadoop against the traditional RDBMS world, cost-based optimization. And then maybe in contrast to Yarn, really cool technology that's even a little larger as Mesosphere. Actually also has a German CEO that lives in Silicon Valley now, good friend of mine. That also is a technology that came out of UC Berkeley, highly used at Twitter or Airbnb, some of those small companies. And it's really all around, again, if we now have basically virtualized computers or containers and we have thousands, tens of thousands of them, how do you manage them? Right, so maybe I have a whole data center and I want to spin up services on demand. So think about Twitter, right? They have, let's say 10,000 machines and 9,000 of them run web servers in a day, but they're totally bored in the night. So maybe you can, again, abstract the whole thing and run a web server in a day and use the same machines in the night to run maybe analytical use cases, right? And increase optimization. So how do you manage this? And how do you cluster incredible cheap hardware together into a supercomputer and really kind of on-demand expand and contract services, right? As there's maybe more and more traffic on the web servers, you want to shut down analytics servers and deploy a web container there or vice versa. Okay, so that's a few interesting technologies. Again, it all goes into the direction of unlimited storage and compute, rethink your architecture, and really focus more on the business problems, because the real value is on the implementing the business problems and not optimization of the code anymore. If I could bring that messages to you guys, then I succeeded. And then it was worth the trip to Berlin in summer. That's pretty much it. And I think we have a few minutes for questions. We'll make that very interactive. We can talk about compiler optimization or use cases, whatever you guys would like to.
So you were talking about deep learning is a big
Yeah.
thing in Silicon Valley,
Mm-hmm.
and Google is investing a lot of money. You said we should not invest more on algorithms because deep learning will, in a while, set up or replace our thinking.
Mm-hmm.
I have a bit a different view, because when I was a student I was working a lot with speech recognition, and we use all this neural network, HMM and so on, you know,
Sure.
these machine learning algorithms. And I saw from the 80s to the 2000, in 20 years, there was just the improvement of, let's say, 0.2% in the recognition rate.
Absolutely.
So deep learning, meaning you have a lot of data, what Google is collecting it for, and you do a lot of neural network in,
Mm-hmm.
I don't know, hundreds layers or even more. So I'm not quite sure if deep learning really helps us, because you said it, it's the data complexity. You need to understand what
Yeah.
do I put in. You know.
Yeah.
That would be also my question to your company. How do you manage, let's say, the complexity that we have with all our data? You know, we have different data, we have different use cases. Which kind of data do we need to use? How do you manage and bring the value for the companies to bring this complexity to tear it down?
Yeah.
That is. And then the second is, would you also go to the deep learning approach?
So I was maybe misunderstandable. Let me clarify what I mean with this deep learning. So here's an observation. So again, we do quote unquote data science since the mid 90s, and what we now really work on is a product that does data democratization. So let me get from here to here. An observation over the last 20 years is that optimizing algorithm has minimal improvements. What you just said, right? Since the 90s, the recognition rate is only increasing by so and so much. Though I see companies heavily investing into data scientists that have no clue about the business, and then optimizing on the different knobs of the k-mean to get 0.1% optimization. But what is incredible, game-changing for a lot of companies, is enriching data to get more context, right? Just increasing the feature vector is so much more meaningful than optimizing the algorithm. And that's what the CTO of Google said, right? We don't have better algorithms, we just have more data. And it's not that they have more data in, like, they have 1 trillion records instead of 1 billion records. Eventually that doesn't make the difference. You just have more context. If you're interacting with Google Maps today, Google Maps is a recommendation engine. Based on the historical observation of your interaction, the context, the location, the device you're using, it gives you different kind of maps. And it's, again, that context. So what we actually see is, if a human brain is just having a more creative association in adding more context to the data, it's absolutely game-changing. Let me give you an example. We work with the fastest growing and biggest gaming companies in the United States. It's mind-boggling. We sold to them maybe 2.5 years ago. It was 30 guys. You know, they're all over the world. Nobody barely spoke English when we went to them. 2 years later, they make $1 or $3 million of revenue on a daily basis. I don't know what they sell, something, pixels. It's amazing. But they run 2,000 Datameer reports on a daily basis. And what they really did is giving everybody in the organization the opportunity to do data analytics. They democratized the analytical problem. Because it turns out that the creative problem solving is still, our brain is still the best. And lowering the barrier between the people that can work with the data, that again, it's now so technical, we have to call them data scientists, and the people that should work with the data, the product designers, the decision makers, the operation, like everybody. that really makes the difference, because now the creative association and, oh, let's add some context here, makes a huge difference. So what did they find out? For example, they look at engagement in the game, right? And they're like, okay, well, how can we add context to engagement in the game? Guess what? They add the TV network schedule. And of course, if there's amazing nerdy TV shows, and I'm not sure if that's even relevant in Germany, Game of Thrones, what's it called? Boom, the engagement goes down. But guess what? Here's a huge opportunity for advertisement. Right? They're not just like, oh, yeah, people not playing our game, but they're also like, oh, we also know where they are, so let's make advertisement there. Guess what? It goes down, and then the peak goes up. So just enriching the context, in the classical weather example, all of our customers do that, right? In the telco, in the retail space, in the gaming, they're all adding weather, and of course, if it's raining, people are more on their mobile devices. Surprise, right? That's not, we all got there, but now adding really. And it's just a public example. We have banks that trade based on counting the cars in front of retailers taking satellite pictures. Okay, so they buy satellite pictures, and then they count the cars in front of the retailers, and based on that they can predict how good the quarter was for this retailer. We have companies that using traffic patterns in Silicon Valley to identify that Apple will bring out a new product, because the traffic patterns starting earlier and go later. Because Apple just has one huge thing and has the same Autobahn exit.
Okay.
So now it's not about deep learning, but it's more about data democratization and more context. And lowering the bar to entry is better than optimizing the algorithm.
I mean, all these use cases
Sorry,
are
that was
true
long.
also for Deutsche Telekom, because we need to enrich our data, we need to understand micro-segmentation and so on, and we want to sell contracts, that is our basis, so we need to understand what the people want to buy. But sometimes I have the feeling I put a lot of features in my feature vector, as I said, and then I get a result. What is the result? How can I validate that it brings me also more business? I get any result, and it can be a hot dog shop that just gives me hot dogs. That's
Sure.
why the people go in there, not because of the Apple event.
Sure. Fail fast. I mean, that's what we see. Look, like a Citibank, they tried the whole data scientist approach, and they have a huge data scientist team, don't get me wrong. Right? Again, the reason they invest in us is because within a year we had 1,200 users of our product. And they basically said, okay, all of the data, small or big, goes into that platform, and then we set up a clean data governance. Right? And there's clean processes, there's technology, there's encryption, there's data masking. And if you normal users, you can't access, Stefan's credit card transactions. But you can basically pull all, I don't know, San Francisco credit card, anonymized mask, and you don't even know which retailer, but it's, whatever the data masking and data governance rules is. And they basically just said, here it is, good luck with that. People are smart, right? And what is really interesting, we saw with many customers, doesn't matter which space, you have that incredible, smart, it doesn't even matter where, which age, nothing. You have that one guy that has an idea, and what happens is that idea runs into a wall. And that wall is maybe, I couldn't get more data into Excel, or that wall is, I was not allowed to use the data at all. Right? And if you ripped out that barrier, then you can have a normal conversation about, that's a good idea, here's some leading indicators, and let's try this. Right? But what we see, again, in a counter to this is building out data scientist labs and having kind of spreadsheets with, there's 5 person involved with doing the use case, and you need to fill out this formal document and put it in there, pull a number, and maybe a data scientist get to it, and then 4 months later, that didn't work out. Right, so what we really saw is that that fail fast democratization. There's something, and then build out on that kind of use case. That makes sense. That's what we see. But that's a tinted perspective because we are in the business of democratizing data.
Yeah, if you go into a discussion in big companies, you always need to validate, this brings something and then you get a budget for that and so on.
Sure.
Now, this culture is shifting, it's going to, try fast, fail fast.
Yeah.
It's still, you need to argue, this brings me that, you always want to see the business case.
So I think what we see is a lot that the companies we're working with that are successful, they, from the top, converting themselves into data-driven decision making. So they basically say, okay, what's your business case to do X, Y, and Z, and where's the data? And you as a business user have to bring the data, and here's a tool set. It's really about the democratization effect. If that makes sense. But again, tinted, right? We sell the product there, so we see that a lot. If we would sell, I don't know, if we would work at K9, or we would say predictive analytics is the magic new weapon for everything. So. Sorry, long answer. More questions? Data serialization, compile optimization.
Very simple question. When the slides show very static and slow growth of the IT budget, the opposite to the very fast-growing data complexity
Yeah.
of this bits, saying this does not fit together. Is it really a question of IT budget rather than business budget? Because CIOs doesn't sell the data complexity rather than the business to give the money. Is that right?
So that was Gartner numbers. So again, kind of the what they predict and measure is that overall infrastructure spend is only linear it's increasing. I don't know how many percent. I can look it up and can show you or send you the link or something. But it's linear increasing. We now have an exponential increase in data, right? So the gap will get bigger and bigger and bigger. But yeah, if we get that shift into data is becoming a business value instead of an IT cost center, and that's what we're seeing a lot, right? So again, that is part of the turnaround of getting to data-driven decision-making process, data-driven organizations, where data is becoming a competitive advantage, and therefore huge ROIs associated with them, where a lot of organizations, that kind of still catching up, Jesus, why would we store log files for more than 3 weeks? Because in those log files, you can understand how how customers interact with you, because they're not going into the store anymore. And even if they go in the store, you have a register and you understand things, or we have retailers that measure Wi-Fi signals and what have you, and how people moving in the aisles. But you now have an opportunity to better understand how you interact with people. And again, it's not personal identifiable information, it's more kind of overall, what's your customer base doing? And then you have a long tail of customer interaction, and then as you're understanding that, you can optimize on that. Right? And not just say, okay, this is like our average subscriber is, I don't know, between 20 and 30 years old and this and that. Right? You can optimize on that.
Just one more question, because let's look a bit into the future. You wanted to predict the future.
I would love to. I tried. I wrote software for that. Didn't work.
According to Moore's law and all these developments, we will have every 18 months we will double the computation power and so on. Let's take Spark and Flink and HANA and all the other.
Mm-hmm.
Don't you think they will replace, because in memory will then not only the 500 giga, but let's say the 10 terabyte,
Sure.
And then we have all in memory and we don't need, let's say, a distributed file system.
The interesting thing is that data is growing faster than Moore's law. So that's interesting. So you have to keep that in mind.
The data that is really valuable, or let's say the data that is a lot of just thrown away.
Well, so that's to be decided, right? I would argue that even in the data that people historically throw away, there's a lot of value because you have time series information, interaction information, right? A classical use case, right? So log files in your IT data center, people just throwing them away after a few months. They actually give you a pattern about cybersecurity attacks. So we have companies that are using our product to process huge amount of log files, to understand how you have internal attacks or external attacks, and how they're actually changing, and based on that then doing kind of firewall predictions and those kind of things, right? They're basically not creating firewalls anymore to isolate machines, but they're basically seeing, oh, here's a viral behavior of this machine, or the traffic is virally changing to this pattern. What means there's a virus or attack or something like this. So anyhow, so I think there's a lot of value in data that people are not yet perceiving on the one hand side. On the other hand side, yeah, look, absolutely, there will be more in-memory technology, and memory gets cheaper. The question is how fast, right? And then again, sequential data access in memory is still magnitudes faster than random data access. What, you know, if every data is in memory, again, if you run MapReduce in memory, it will still be faster than kind of a B-tree data access. But we'll all mix, right? And then you get back to that, what I described. You start with raw data and you cook it down. And MapReduce is great here. It doesn't matter if it's on spinning disk on SSD or in memory. It will be always faster, and then you have maybe random access here or something.
Just one last question.
It's okay, as many as you want.
I'm interested in, is there a, let's say, a big ecosystem in the Silicon Valley around this topic, and how does it evolve?
There's, yeah.
Yeah, so
Of course.
Stanford is producing more and more spin-offs, or how is it? How
Yeah,
can you
well,
imagine the scene there?
There's MPLabs at Berkeley, right? They're pushing really hard, and it's interesting to see. So Stonebreaker, Professor Stonebreaker, who kind of invented RDBMS, who hated Hadoop, now he has a Hadoop startup. Right? So,
So about the money, is it?
yeah, sure, maybe. I mean, what's interesting, the market decides on topics, right? So, the market's moving very quickly in the West Coast in general, not just Silicon Valley. We have an ecosystem, yeah. It's funny. I show you a picture. Frank and me and 6 other guys for the first Hadoop meetup, and I show you a picture. 5 years later, 300 people at Yahoo. It's growing very quickly, right? And it's arriving at Europe. That's pretty cool. So you guys are an example, right? You have internal meetups. There's a Hadoop meetup that Isabel Dorst runs since years, right? And the first few meetups was like less than 10 people, and now it's getting bigger. It arrives. Europe's always 3 years behind in the adoption. That's interesting. But it has amazing engineers. That's why we design in California, we manufacture in Germany. And it's the cross-pollination is what drives the innovation. Right? It's a different kind of technologies, the hardware people coming together with the software people, the business users, the use cases, right? And that's kind of they're very open about that. Sure, you sign NDAs, but the telcos go on stage and do keynotes and say, this is what we do. And by the way, we're hiring, right? And it's more about, look how innovative we are, and why don't you work on really interesting problems to attract really amazing people, rather than, well, we don't tell you what we do, but do you want to work for us? And people have a choice today, right? And
But once you're hiring, I mean, we're also looking always for talented scientists. What is your skill profile? What
For
are you
us?
looking for if you want to hire someone? I mean, if they're young, I mean, if they're young guys coming from the university, they have a master or a bachelor, they come to the market and they, so how do you
For us as a company?
see a good data scientist could work for you?
so again, we hire actually less data scientists. We hire more Java engineers because we build a product that is then used by, we heavily use by data scientists to do data prepping, but it's more kind of the day-to-day business user or business analyst that use our product. So it's a very low barrier to entry, right? If you can use Excel, you can use our product. It's that simple. It's just Excel on steroids. You have 1,000 node Hadoop clusters in the back end. It's more fun than Excel, by the way. Look, what we're looking for is learning agility. So that's our number one thing. If people are willing to learn, we teach them everything. Right, and we actually stopped trying to hire the purple unicorns, how we call them, the most amazing, 25 years old, 20 years of work experience, PhD in math and Java programming skills kind of guys. but we're just trying to hire curious people. We're looking for, hey, did you do some open source work? Are you interested? Do you have a general understanding? We teach you the best. Right? And we really buckle down in enablement. And that then cross-pollinates within different departments in the company. We rather hire people that would love to learn and are sponges rather than ready-formed people. And we're looking more for cultural values beyond that, because then there's more interaction. Yeah.
I would like to go back to the business side.
Yes.
Yeah, and I'm curious to see more on this new and real life use cases you can
Sure.
show or elaborate on that. I like the first part, but I think the other one would be...
So we double-clicked a little bit on value-based capacity planning in telcos. Let me tell you about that.
That's good.
So upgrading cell towers is extremely expensive, right? Margins are going down, so you have to be very thoughtful if you want to update that cell tower in downtown Berlin. Historically, capacity planning and the software you're using runs on Oracle, static schema. You're doing capacity planning kind of based on the solution you have since 10 years the same way, right? So we had, again, many telcos in the world, around the world, Europe, North America, Africa, Asia. They're using basically our product to take the traditional data sets for capacity planning, enriching that with behavior, with CRM data, with behavior data, and even with customer complaints. So what you basically now can do is to say, okay, I have a cell tower, and I'm not a telco guy, so I abstract that really highly and can try to dive in, and Peter can go into detail. He knows the use case inside out. But you basically now can bring different data sets together, context as I mentioned, and you can say, okay, here's a cell tower in downtown Berlin, has 5,000 subscribers, of which 3,500 are on the edge of their data plan. So if you increase the bandwidth, and we know that they all love SoundCloud and YouTube, if we increase the bandwidth on this thing, they will all burn to their data plans. Right? Because now you brought in their behavior, how many streaming do they doing, not what they stream, who cares, right? But hey, there's streaming use cases in those guys. And we're also now, if SoundCloud has more capacity, they stream at a higher bit rate, right? So there's more data sets. So if we increase the capacity on the cell tower, but you can look at the cell tower in, I don't know, what's the fancy, outside Munich, the fancy little Örtchen. Anyhow, if you go like in a super expensive outside Munich, guess what? The usage behaviors are different. There's a lot of devices, and they're all like the very greatest and latest devices, iPhones, what have you, but they're not streaming SoundCloud, right? So the traditional, you can just enrich more data, and again, this is just the beginning, right? You can enrich as much data sets as you have to add more context to be more precise about where does it make sense to upgrade to LTE, for example. And we did that many times actually. It's an incredible, valuable use case. Same thing, churn analytics, right? Historically, you run churn analytics in SaaS, you have your data scientist, and you do kind of a customer metadata. If you add behavior data from your website, because you can identify the same user because they log in, check their balance online, you set a little cookie, and now, they keep checking out the new iPhone, well, they're in the market. If they check out new devices, they're in the market. So there's a risk associated with that. So now you can make a more informed decision based on behavior. So for example, maybe not in the telco space, but in insurance, one of the biggest insurers in the United States, we lowered their churn rate by 50% by just adding more context. It's a little bit different because the velocity is not as big, right? You don't change your insurance every year or every 2 years. I don't know what the average lifetime value or lifetime of a telco customer is. But if you, in an insurance, go into the portal and looks for the terms and condition, it's very clear risk sign. And now we can calculate the risk score. We push it in the CRM system. If people call into the call center, we route them into a retention team. It says, hey, well, can we talk about our retirement products, for example? I would do a lot of those kind of things. Really, again, bringing structured and maybe unstructured data or log files together to then just give an extra kicker to a risk prediction or upsell opportunity. do a lot of credit card marketing optimization where you have, it's maybe not prominent in Europe because we work differently with credit cards, but the average American has 7 credit cards. I don't. How many credit cards? You only have 1? Oh, German accent, huh? You basically see, okay, well, you keep buying, you don't buy gas with your credit card anymore. So most likely you didn't get rid of your car because you're still traveling the same distances every day, right? You buy groceries there and you buy your lunch there. Most likely you got a credit card from your gas station. Or some other credit card where you get more points for gas. And then they run campaigns against that, right? And they offer you more points there, or this, or give you a call, or send you a mail, etc. And again, not limited to the United States, in Europe the same thing. Under data governance laws. And I don't need to know that's you, I just need to know there's a pattern in the overall, and it's all anonymous, etc. What other use case we have? The classical thing, who bought this, buys this as well, recommendation engines. Peter, what else do we do? Oh, do you want to talk about
I think
Freddy?
the most critical thing is this time to insight thing. How long would it take you to do that with traditional technologies, right? I've done this project with the Telco in Munich actually. We came in there and they really struggled with all
Peter,
this
you want to
integration process.
come here in front of the camera?
Oh, sorry. No,
Come in.
No, it's fine. Okay.
Well, they want to record. You have a nicer jacket than I don't have it.
Okay. I can do the dance now. No, really, when I've done the telco use case specifically for network optimization, we came in there and they really struggled with the data preparation and data integration piece. So they had all technology on the planet, right? It was awful expensive, that's another story, but it was actually too slow to get from the raw data to actual insights. Okay, this is what Stefan mentioned before. It takes them 6-12 months to get insights from data. Okay, and with this new approach, having no schema, right? And you really have to rethink if you're, an BI or data warehouse guy. You really have to rethink how analytics can be done efficiently today. And not having a schema that locks you into the question you have asked to the system or defined into a schema before, that's the real value actually. And that brings us down to development cycles of weeks, or a bank, for instance. You asked for feature extraction, for instance, right? What patterns in features, and this bank in Turkey, Stefan is going to visit on Wednesday. They have about 1,500 attributes in their systems, and they have no idea, or they have just a sense which are relevant for a customer that is not paying a loan. Okay, and extracting that features takes them 6 months. Okay, but what happens when this customer then, what happens in between, right? And we took that down to 5 days, right? And being much more agile in this development cycle, that's the case for Hadoop actually. Okay, and that's I think the biggest point, this no schema approach, and being super agile in doing analytics. And of course you have the nice cost benefit of 1 to 50.
There's maybe one more. One of the biggest banks of the world, they did customer upsell optimization. Historically run it on SaaS, $20 million platform. They run 500 million attributes. Execution time was 36 hours. They took the PMML, so you can predictive model markup language. You export it, you run Datameer. They run it now on $1 million platform with 7 billion data points in 50 minutes. So 20 million, 1 million, 1/36 of the time, right? So you can just run it more frequently. Okay.
Yep.
Well, thank you.
Thank you.
One more question.
Yeah,
Okay.
I have one last question.
Okay. Compile optimization.
It's back to techniques. So my question is, you talk about Spark, you talk about Hadoop. from the end application developer viewpoint, if I want to build something for streaming, for batch, for machine learning, as end developer, what kind of API should I take as first choice? Like I sit upon the Spark API, or I use a low-level Hadoop API. What's
You
your
definitely
suggestion?
want to get higher up, right? So as founder of Datameer, I have to say you can point and click it together on our product. But if you want to code it, I would recommend something like cascading, where you have a higher level API and it compiles down into the different execution engines like Spark, like MapReduce, or other things. So I would, if you want to code something, I would recommend cascading. But we can do a competition and see how fast you code and how fast we can point and click. So, but yeah, cascading will be the right choice. Okay, happy to answer other questions there. Thank you for your time.